To give some context to and takeaways for today. So I'm Ryan Manning, first introduction. I run Bad Rhino Studios. We're an independent studio, authorized partner with Epic. We have been indie since the start. We're about 35 folks. Why I say all that? Because with us being distributed, source control has been paramount, especially to the fact that we work on many different projects. It's important that source control basically saves our bacon. So one of the big key takeaways for today's talk is if you're not using source control currently, you plan on using source control, or just trying to do things better, saving your bacon is super, super important with that. So that being said, here's kind of the agenda for today. I'll try to leave some time at the end too for questions, in case anybody has anything. So we're going to go through source control that's currently supported in UE, just a general overview of the platforms. We're not going to go down into the weeds necessarily. This is a very important one too. Using source control in UE, more so just allowing the engine to help you better with your source control and let you know when things need to be checked in, checked out, and then how to go point the finger at somebody when they break your stuff. Which would be good. We'll also talk about some source control workflows. Again, coming from an indie perspective, showing just good practices for how you can utilize source control effectively as a team, especially from a distributed workflow. And then we'll also go through some of the topology setups. Again, we're indie. If anybody else in here is indie, you know budgets are non-existent. So go through and just show you how we've been able to build basically a ridiculously lightning fast Perforce setup, even working in distributed stuff. So, and then at the end, if we've got enough time too, I'll just show you some good kind of mental thought process to go to when you're using source control inside of the engine with your project and how you can start segmenting. So again, if you guys know anything about source control, one person can check out a file at a time. So make sure that you guys can stay working pretty well. And apologies, I'm losing my voice. All right, cool. So let's go through the current source control platforms currently supported by Unreal are Perforce, Git, Subversion, and Plastic SCM. For today's talk, I am going to focus more on the Perforce side of things, not to say that I'm biased, it's what we use. And the primary reason you'll see when we get to the pros and cons here in a second is Perforce and Plastic SCM are the two strongest right now in terms of workflow, scalability for your teams and as you grow. But Git and Subversion have the lovely price tag of free, which is awesome. So we'll dive in with Perforce, just some of the pros. I won't go through the extensive list. You guys can feel free to take a picture. One of the big ones is supports file locking. For anybody who's working distributed, thanks to pandemic, a lot of us were forced into that. You'll know that sometimes communication can be sparse. So using a source control program that actually locks the file and lets other people know, hey, it's locked is huge. That prevents merging conflicts down the road. It allows you to really know who's working on what so you can stay out of their lane. One of the nice big pros with Perforce is that it does have a front-end GUI, so artist-friendly. I'm an artist by trade, know enough engineering to break things, and told not to touch engineering. So having the visual front-end is super helpful, especially for your team. There are some really cool built-in tools as well. So diff, being able to compare differences between files. Swarm, I'll actually show a little bit later here a screenshot from that. But if you're working with an engineering team, I think we've all been there where blindly submitting code and not checking can cause lots of problems. So you can use a tool like Swarm to be able to do code checks, reviews before things go mainline. And this one too is not an understatement. It is an industry standard in the games industry. It's been around for years. One of the cool things about Perforce is it does support small teams, but it does scale extremely well to enterprise levels and or loosely translated. If you're working on a lot of stuff, you got a lot of files. Works extremely well. Just a couple cons real quick. It can get expensive. I want to be careful not to cast any bias, but obviously using Perforce yourself, we know some of the costs that go with it. Managing it yourself is great. Perforce does have a cloud-based option, but as you guys know, anything cloud-based gets expensive pretty quickly. Talking about Git real quick, free, love free, it's open source. Git is pretty good, but I will say this, it's not a super artist-friendly program. It's definitely more for engineering, which is a good thing. That's actually kind of how they got the bread and butter started with it. There are a couple things. You can't do file locking natively, but with LFS 2.0, you actually can. It is an add-on to it, more so like a plugin that you can use to be able to do that. And the other thing too is just to keep in consideration, again, is not very scalable for large teams or lots of projects. Then SVN, very similar to Git, free. It is open source. This works pretty well. There is no native binary, or it does have native binary file support, but the important thing to keep in mind is it actually does keep a second copy of your project. So it does get a little bit bloated per se, but again, hard to beat free. And then finally, Plastic SCM. So this is one of the, I say new runners to the market. I've done a little bit of work with Plastic SCM. I do like it. There's a lot of promise to it. It is kind of picking up the pace from where Perforce has not really adapted too much. Again, not to say that in a bad way, but they're doing some really, really good things with this. So again, pushing less out of feeling like you have to be an engineer to manage your software. Plastic does a really good job of that one. Their branching and merging is extremely nice. I will say, in fact, that it's usually faster, typically, than Perforce. If you guys aren't aware, I'm sure most folks in here, typical UE projects when you start are about anywhere from 50 to 100,000 files. Obviously, depending on the nature of it, they can get upwards of 1 million files. So being able to do those calculations is very, very important, especially if you do it quite often. And then really the only con per se is it's relatively new. I don't want to say relatively new and Unreal. We recently supported it not too long ago. But just keep that in mind that there is some of that early adoption just to keep in mind. There might be some quirks with it, but again, very, very good program. And then of course, here are just some additional resources. Matthew Doyle did a talk on this as well, so I'll keep that up. Very, very good about getting down into the weeds of each platform if you guys are interested with that. Key takeaway number one with this one is if you're not using source control, please use it. So it will save your bacon. Perforce, I do know, offers, I think it's like a 5 and 5, so 5 users, 5 free workspaces. Just keep in mind though, as we'll actually see here in a little bit when I start talking about streams and all that stuff, you create a new workspace for that, you can quickly blow through 5 workspaces very, very fast. But it's a great way just to kind of test the waters per se. I will say this is a good recommendation. If you do game jams, you're a super small indie, absolutely there's no reason, spin up 5 and 5, you'll be absolutely perfect with that. Okay, so let's dive into a little bit of our source control UI. Super easy to enable source control in Unreal. So simply just go to your plugins and just choose which one that you want. So we can see there's all 4 there. So our Git, Perforce, Classic SCM, and Subversion. Again, this talk is more tailored towards Perforce, but trying to universally apply these across all of it. One of the things that I also want to make note of too is that what you see in the engine, so enabling these plugins is not like a standalone application. And what I mean by that is it's not a special integration when you do this to where like if your source control clients update, you don't have to update the engine. All of the source control plugins here actually access the backend systems of your source control, meaning you literally just turn the button on and that's it. That's all you have to do. And then finally, to be able to connect, so this is assuming coming from you on the user side, in the lower right of the editor, all you simply have to do is go to connect to source control, choose the provider, put in your information, and Bob's your uncle. So very easy to do, simple check mark will come on. I'll make this very good distinction. That gives me the warm fuzzies at our studio a lot because without source control, you guys, we'll see here in a minute too. As soon as that is connected though, the engine is gonna be prompting you throughout if something changes or there's dependencies, which allows you to make sure that whatever you're working on, other folks will be able to get as well. So it's literally that easy. And then some of the nice contextual helpers inside of the engine, once your source control is enabled, you can do things like check out the files directly. Again, I think it's in the next screenshot. You'll see when you do check it out, it still goes back to the original client. So in this case, again, talking Perforce side, you'll see your files are actually checked out. And then in the lower left, you can see the red check mark, which means you own that file right now, you're making the modification. The exclamation mark means this has not been versioned, just to let you know. So you can add it, you can do whatever. And then the question mark again is we're not really sure. Oh, I'm sorry, reverse that. Question mark, you have not checked it in. Exclamation marks means you're out of date. So I think from that screenshot alone, that's one of the biggest helpers, because one of the things you don't want to do is say you're working on a file, you're working on a level, and if you're not using source control and you don't know that the files haven't been updated or you just forget to sync, this is a great way just to remind you, hey, just to know you need to update. And then this is probably the other thing that occurs on a very frequent basis, especially for us when working on projects, is whenever you modify a file, the engine will pop up this little window in the bottom. It's nice, it's out of the way, and it'll just say, hey, by the way, you've modified 5 files. Do you want to check these out? The cool part about it is the engine is smart enough to know the dependencies. So say, for example, you're working on a blueprint that has nested 4 other objects in it, and you need to check those out. The engine will prompt you to go ahead and check that out. Which is great because if you guys have ever worked on very complex projects and you forget the dependencies, it's a pain because you wonder why things are broke and somebody realizes, oh, I didn't check it out. The other thing here too, and we'll see this in some of the workflows, is you also have the option in the middle there to make it writable. And essentially what this does is this unlocks the file locally on your system so you can modify it but not check it out so you don't block anybody else. And then you can, of course, check it out, push it later, but it just makes it available on your local system to be writable, which is super helpful, especially for reviews, if you just want to modify something but not check it out, not block anybody. And then, of course, this is, if you're not familiar, this is P4V. This is the visual front end for Perforce. And as you can see, checking those files out, it does, in fact, just add it to my default change list. So your same workflow applies exactly the same. You're not, again, Unreal is not a standalone Perforce or source control client. It's always going to go back to the original. And of course, you can do the exact same functions you would as normal. Okay. So let's dive in a little bit to workflows. And again, I apologize if some of this is known for everybody. Biggest key thing that I'm hoping, though, at least everybody gets a little nugget of knowledge from this one, is I put in a few different workflows that we've encountered in our process that you will most likely encounter as well, given current workflows and current production techniques with Unreal. So this is like a very simplified, kind of typical workflow. So assuming, again, we'll just take it from the aspect you're working on a project in Unreal, you're using source control. First step is to sync your latest, so the Perforce client will know, or any of the others will know which files are out of date, update it for you. You will then do something, probably just work on files. And the 2 options, as we saw too, we can save our work locally, or we can go ahead and check out the files in the depot. The source control client will also let everybody else know, hey, so-and-so is working on this file. Fun little tip, don't have your files checked out for too long. People don't like that, so check them in pretty regularly. It's great. And then we have an option to whether we can push the files directly to our depot or we can stage them for review. Regardless, this is one of the very important underpinning principles when it comes to source control. Your files are not versioned. You don't create a separate version of that until you push those files. One of the things, too, that I'll make note of is a lot of folks who are new, especially to using Perforce, one of the questions that comes up a lot is, if I push a bunch of revisions in my files, isn't that going to bloat the server? Great part about going back to one of the being industry standards, actually those are extremely lightweight. I want to say that in our current repo, the last I checked, if it was fully uncompressed, I think we have close to 70 terabytes of project files spread out. But our depot compacted is actually only about 6 terabytes, so it's super lightweight. The key part here, though, too, is both from the user perspective and then just as like a good studio practice, is just make sure you push those revisions so you have something to go to. So this is what I was talking about, too. So this is Swarm. This is one of Perforce's clients that allows you to stage your code review. One of the other nice parts about this as well is the ability to shelve. So 2 separate systems, hopefully make that distinction here. But basically the idea is that you can do your work, you can submit it, but not to the depot, but to a place where, again, if you're working with somebody else, maybe you've got a lead or somebody who's doing the code reviews, they can go in and pull those files. So they are, quote, versioned, but not everybody else is going to have them until you unshelve them and push them back to the project. So this is a great way, especially if you're working on technically complex projects and not casting shade, but maybe if you're a junior or somebody and they're still trying to learn the ropes of systems, or it can be a senior too, doesn't have to be anybody. This is a great way too, where you don't upset the project, which is very important. We all been there, it's ship date, but somebody wants to patch something, that never goes well. So this is a great way just to shelve those, check those before you commit. And then this is something I think everybody will encounter at some point in production to where you need to go back to a revision. So going back to the principle I talked about a bit earlier, why it's important that you push often. So in the lower section here, we have 4 versions. And in this example, version 3 is our current on our depot. So just kind of keep that in mind. So the idea here basically is that you're working on files, you're syncing, our typical workflow, but maybe something happens, right? Maybe you do something, you break it, somebody breaks it, and you need to go back. Again, principle number 1 here is make sure you have that history, right? If you don't check in the files, you don't have the history. So check in often, check in regular. And what you'll do is you can diff against it, or you can just pull that file in. And this is what's really cool about our source control workflow is, say for example, version 3 broke, but version 2 was good. I roll back to version 2, I now create version 4. So you don't lose that history. Maybe there was something in version 3 that was still good, but not suitable for release. Absolutely fine. You can go back, pull it, you create your new version. And then this is the other one. I always joke about this one, especially around our studio. This is the blame feature. In source control, you can actually do this inside of Unreal. You can do it inside the clients, but you can actually pull history on the files. And a lot of times what this helps out in production is to figure out who last touched the file, or maybe something happened with that file and you just need a question answered. So inside of the editor, again, this will pull the information directly from the source control client. You can see who did it. So in this case, it was me. I broke it. It was my fault. I can go in there and I can diff against it. I can look at it. Again, just to keep on track, keep on target. And then this, for example, is the Perforce diff tool. Again, this is, I know it's tailored more towards the Perforce side. Some of the others do as well. And in this case, this is one of the materials which does have, you do have the ability to actually see the text base of it. And what's really cool here is that even though it's not the most artist-friendly, the green that's actually on the right, I can see where things had changed, what I had modified. So this is a great way just to quickly debug, go back, figure where things broke. Extremely useful. And then I've also got here just some, I'll kind of go through these, just kind of scrolling, but this is the built-in blueprint diff tool inside of Unreal. So if you're not familiar with blueprints, outside of Unreal, you can't really diff against them easily. So this tool's been in for quite a while. It's very robust, especially in UE5. It took a nice leap in functionality. And you can see here that what it does is on the left, it actually shows us what had changed from revisions. So I don't, just go with me on a journey here, little lazy there. So the right-hand column, that's my local revision, and I'm diffing against, in this case you can see there, revision 4, the CL it was attached to, and the date. So it shows me what had changed, what I've modified in a visual way, which is super helpful. And the blueprint diff tool isn't just for like text or nodes. It can show you anything nested with those assets. It can show you connections and see what changed, when it changed. And again, save your bacon to go back to figure out when did it break, why did it break, how can I fix it? And then this is one of the other workflows that we encounter a lot. So if you guys have ever built or worked on worlds inside of Unreal, there's many different approaches to how you build it. I'll show a couple actually towards the end here. But oftentimes, you may have multiple levels, sub-levels, again, assuming we're not using the new open world tools. But you may, in fact, have a level that's comprised of several sub-levels. So the idea is, with this one, I need to roll back to a date and time, not a specific CL, right? Because there may be several people working on the file. So how do I do that? So one of the cool tools is the ability inside of your Git revisions. So on the left is actually a screenshot from the Perforce client. Simply right-clicking, Git revision, and then from the pop-up, you see here you can specify a date and time. What's extremely helpful with this particular workflow, you don't really have to know the CL when something changed, why it changed. You can simply just roll back to a time. And then, of course, Perforce will go back in, so kind of using this. You can see at the bottom that version 1, 2, and 2 happen to coincide in this example with that date time. And now you have it, and again, with the same workflow, we can commit those changes, compare them, pull things, whatever we need to. Okay. So now the fun part. So I'm going to try to make this not super boring. Again, take into consideration, at Bad Rhino, we are an indie studio. So budgets are tight. We have to be extremely diligent with the things that we do implement. But at the same token, too, having a distributed team, it's important that our folks have speed, connectivity, reliability. and they're able to push and pull files quickly, because as you guys know, you do that on a regular basis, that can quickly get into a huge time suck. So I'm gonna go over this, I'm not gonna try to go too deep. If you guys do have questions about deeper stuff with this, absolutely we can talk about that. But I wanna talk more about some of the hardware topology setups, hardware capabilities. Fun fact, little spoiler alert, I like being a little cheap, if I'm being honest. So being able to like hack ways where you're not spending thousands, hundreds of thousands of dollars on systems to literally get enterprise grade stuff, I'll show you guys that as well. And then there's one screenshot in here that I will stop, so you guys can grab pictures of. You can thank me later for this one. We have spent years trying to tune our Perforce, and sifting through documentation, help support. I will show you guys actually the commands that we use, which have made it extremely beneficial. So there's a couple options when it comes to source control. There's your local access. Now again, we can call this headquarters. We can, it could be like a physical studio, but the idea being that you have physical hardware located at a location. Some of the pros with this too is that if you are managing your server, your topology yourself, you do have the ability to upgrade it when you need to. So if the needs arise, start cheap, build up from that. You can as well for restricted access. I know all of us have probably worked on several different projects where NDAs are heavy or they're very, very important clients. So being able to have a local one, that sometimes is a no question. You have to have it. And then one of the other really beneficial things is, so in our situation, our setup, we do utilize a 10 gig network. So if you guys are familiar, most typical networks are like 1 gig. 10 gig gives us like theoretical speeds that are redonkulously crazy, which is super helpful. So from a local perspective, that's a great way to keep speed. And then, of course, there's the cloud option. And I think the thing is, we all know, anybody who's kind of looked at cloud-based stuff, it can get expensive extremely quickly. Not only do you need to have the server side, but oftentimes you'll need to have the storage capacity with that. And again, not going to cast any dispersions on any cloud provider, but typically they have a cost associated with however many terabytes you need, that's what you pay for. So there are ways you can ramp up and down on that. So say you start a project and then it's going to go into archive, you can then remove it, save some cost there. One of the other things though, I think so, to kind of talk about the pros is for decentralized teams. If you guys are aware, kind of like, not gonna go in the history of networking, but whenever you're accessing cloud-based services, typically there's like a massive fiber backbone. So you get these crazy speeds. And a lot of times it has to do with replication. So using the example like Google Docs, right? Say that I'm in the US, somebody's in Portugal, somebody's in Australia. When I load a doc, what they see is actually a shadow copy that's moved around. So, but extremely, extremely quickly. So being able to use the cloud-based things, there are some big advantages to that. We have run into bottlenecks ourselves. A few of our folks are actually based in South America. And one of the things that we encounter a lot is one of the ISPs in between us actually slows down a connection. So being able to use a cloud-based server or a cloud-based solution is actually a really great way to kind of help speed that up. And then you also have the ability to cluster servers. So this is something I know Perforce offers in their Assembla, which is their cloud-based option, that you can actually create clusters of servers that basically do the exact same thing that all these cloud providers do, to where that server can be locally based closer to other folks on your team, but it will constantly replicate itself, which again is great because you don't have to manage it, somebody else does, and you get those speeds. And as I mentioned too, so this is something we've run into. At the height of the pandemic, we moved a lot of our systems back into my house, actually, is where I have it. And this was something very interesting that we discovered that's not really known, but my ISP, because it's classified and categorized as residential, processes through a different backbone. And this was in the example, some of our folks in Argentina had the issue to where it routed through New York because it was classified as residential. So there are considerations there too, that by being in the cloud, you're commercial, you're prioritized, et cetera. But again, that's one of those things I'm not gonna say is a deal breaker, but it's definitely worth keeping in mind if you are floating between a local-based solution or cloud-based, it does happen. So this is actually our setup. So we have a data storage server that we use, dual Xeon PCs. Trust me, I know it sounds really fancy. Those are actually just old server ones that I picked up off of eBay. So you don't have to have the latest and greatest hardware. We do have about 256 gigs of server memory, and the primary reason for that is this server actually acts as a VM. So jumping a little ahead of myself, if anybody here or anybody watching works with consoles, you know that there's certain software that you have to have on that machine. And sometimes when you're working on multiple projects, that's not ideal to constantly try to have the different variations of the SDKs you need. So we've double purposed over our data storage server to be able to act as a VM as well. So as we're working on a project, say it's with the switch, we can just launch a VM that's pretty lightweight, have the tools, and our developers can directly access that through our VPN. 60 terabytes of just XFS file format, if you guys are curious on that one. But that's essentially just where we store everything. So we've got our server, and then this is one of the keys with our particular setup. Just using some simple SATA SSDs, we just put together 4 terabytes in a cache pool. Cool part about this, and I think this is where it's important, relatively low cost, but now we can push across our network about 9 to 10 gigs a second is how fast we can push files. So it makes a huge difference, especially going back to the example with consoles. If you're working with Source Engine, you have to push all the files, right? With a Marketplace version, it's all localized, but using a Source version, which often comes up, you're still gonna have to push those files. So that little setup there works extremely well. And then for our server, again, using Perforce as our preferred kind of client on here, this is just a run-of-the-mill AMD Ryzen. There's nothing fancy about it. It's not a server CPU by any means. We do have ECC memory, important there. It's important, especially with the amount of data transferring back and forth, that you have error-correcting memory. And then this is the meat and potatoes of this one, which is our 1 terabyte. We have an M.2 SSD RAID, basically where we took 4 ultra high-speed Gen 4 hard drives, rated them together in a RAID 10, and that gives us a theoretical push of about 27 gigs a second. So whenever all of our clients are pushing, so whenever they're trying to push data to it, that is as fast as they can go. But of course, then we're limited by ISPs from anybody remote. But the key here is that from our perspective, we don't want to bottleneck our developers on potential speeds. So that's actually been a huge lifesaver. And then, yeah, it's actually true. The cost to build all that was actually about less than 10K. So I'm hoping that that stands out at least for, again, from an indie perspective. You don't have to sink a ton of money into it, but you can have a very fast, very reliable, file system server and source control for your folks. And then this is just to show some of the topology examples. As we go through this, the one thing I probably want you to keep in mind as we're doing this is the idea of security and compliance, but also speed and balancing that. So, trying to make ways that we unblock our folks from being able to access the project files that we need to, but also making sure that we stay security compliant. So if in the event anything happens, we all know about leaks, that there's a way that we can quickly lock things down. So in this particular example, this is one of the things I had mentioned, that Perforce does offer this option. I will say, though, it is a little bit more technically involved. It's not just as simple as push a button and it goes, albeit the cloud-based version kind of does this for you. But in this particular example, we have our local Perforce server, and then we have remote ones. This solves a need that we've seen. Now, we have not implemented this, just being honest, because it's more of a cost thing. But we could easily spin up, say, for example, a cloud-based storage things, as for example, like AWS, Cloudflare, et cetera. And then we could put a remote Perforce client, a remote Perforce server, and it will synchronize between that. I have seen this come up in situations where, say, for example, you do have, like in this example, a Portugal office or an Australian office, and they're constantly getting slow speeds. This is a great solution to be able to solve that problem. So you still manage your Perforce server like anything else. It's transparent to the users. But the cool part about this is you have that replication. So that server will be based closer to them, which means they have faster access to that file system, and you don't have to worry about the synchronization. And this is one of the other things, too, is talking about access restriction. If your source control is open where everybody can find it, tisk tisk, shame on you. You should be hiding it. But there are some options. So this is one that we implemented early on in our studio because it was a great cost-effective measure. Again, if you're working in a situation where you don't have the option of having a commercial ISP where you can have a dedicated IP, you still need to have folks to be able to connect to it. So there are dynamic host providers out there such as NoIP, Google Cloud DNS, Amazon Route. They're super easy to simple to set up. And basically what it is you have just a small little client on one of your machines every so often just telling these providers, this is my IP right now. So your end users, instead of using a constantly revolving IP address, can simply use something like perforce.mysite.com or whatever your studio name is to look really cool. That's what they will do to connect. So this is a great way, again, a very cost-effective method if you don't have the ability to have a dedicated IP. And then the other thing here too is now we're starting to kind of dip into security things. Perforce, which does have a very robust security suite, you can see all the permissions are managed through Perforce. So in this example, we could just say users A, B, and C are employees, and maybe users D, E, and F are contractors that we bring in. You see everybody connects the exact same way, but we manage the security of the Perforce depot through our permissions table. Again, super simple method. You start getting a little bit more complex. Again, I'm going to try to stay high level on network topology and setting this up. If you're not familiar with a VLAN, it's a virtual LAN. It's just a great way that you can segment out your network without having to have two separate networks or multiple networks. It's a great way to do it. Cool part is you set it up once, and ideally, you don't have to touch it again, and it works extremely well. So in this situation, again, we've got the same thing, whether we're connecting through a DNS provider or direct IP, you'll see that we still have our users A, B, and C, and D, E, and F all connecting through the same thing. But in here, we're using the ability to take a VLAN and segment things out. So maybe there's employee resources we want for our folks, and then there's separate contractor ones. We can utilize that VLAN so they can still get access to those, and the end user gets what they need, they get fed, they're good to go. And then, of course, we're still back to our permissions table in Perforce so they can access the local Perforce server. I will say this just to put some good contextual handles on what something like this would cost. It's actually pretty cheap. You don't need commercial grade hardware to have VLAN. In fact, there are several commercially available routers and switches that you can do where you can easily set this up. We're talking only a couple $100 to be able to get this kind of topology. And then this is more so what we're actually currently using at our studio right now. The key part is on the left, that's the save your bacon. I'll explain that in a little bit. So we still utilize kind of the same workflow, albeit we've actually put in a corporate firewall in there. Again, they're not super expensive, but it's really great. As you start working on some great projects, everybody wants leaks because that's awesome. So having just an extra layer of protection is great to be able to help you out. So still using the VLAN tags here to segment out different resources. We have our Perforce permission table as well, handling all of our connectivity, and everybody access it. This is one of the big things. I know early on in our studio there was this kind of notion that we're working on some really cool projects, but how much of a backup do we need? I would recommend it even if it's just something. But right now, where we've kind of come to is we have an offsite backup. So in the event a catastrophe that happens, we still have an ability to pull those files. They're semi-safe. Lots of providers out there that will do this. One of the cool parts is we've actually offloaded that task, so it's all completely automated on that file server that we built. So it does it all automatically. We don't have to worry about it. Albeit, if you do that, check it because stuff happens. And so we've got that. And then additionally, we've got an on-site backup. So again, with the understanding that right now we're about 35 folks and growing at our studio, it's important that a lot of data is moving in and out. Trying to pull from maybe a cloud-based offsite backup might be too slow. So we actually just have basically what was another file storage server, exactly the same hardware specs as the other one, but that acts as our on-site backup. So again, if anything happens, we have that as a potential backup plan if we ever need to implement it. So knock on wood. Hopefully we don't. And then kind of lastly with this one too, this is what I was talking to with just security and compliance. Again, stuff happens. So it's important, especially as you're thinking about, if you're one of the key decision makers in building the topology for your source control, think about the logical breakpoints where you could throw, the switch, right, and prevent access to those systems until you have to investigate. So that's why in our current setup, you can see here, we've got many different points that we can cut off until we can figure out if something does happen. So it's very important to kind of keep in mind when you're building this out. For just some contextual handles on building something like this, the cost of this, your initial hardware cost, maybe 10 to 20,000 for all of your hardware. That's a one-time purchase. And then minus the offsite backup, most of this other stuff you don't have an ongoing cost for, minus electricity and stuff like that. So this is a great solution, again, if you're like a kind of a mid-level indie or a smaller studio. This works extremely well. And the other cool part here too is that this particular setup could actually scale to anything of your large size indies, right? Like 150, 200 folks. This topology works beautifully for that as well. Okay, that, if anybody wants to take a picture, go for it. That is really one of the keys. So this is what we took a lot of time to build out. Now this is specific to Perforce, but I think here, if you guys do kind of see, a lot of these are just network systems. So TCP size, buffer size, et cetera. We spent many, many years trying to get this tuned in exactly perfect. So this one in particular, all you have to do is on the Perforce server, there is a command that you just type in p4 config show, and it will show the configuration for your server. By default, most of these things are actually turned off. The key things that I want to highlight here are turning off your auto tune, turning on parallel. So basically what this allows you to do is whatever you specify in that value, so currently we have 8, whenever somebody is pulling a file, you can think of that as a single connection. By enabling parallel, you can actually allow them to do that 8 times or whatever you specify at a time. It's important to note that your data throughput is important on this one and your hardware because you want to make sure you don't overload that. But that was a beautiful lifesaver. Here's the fun part. We didn't know about this one. Net auto tune by default is turned on. If that is not disabled, it doesn't matter what you set in your parallel, it doesn't work. So by flagging that, you actually take advantage. And that was by far one of the biggest advantages that we actually had with our team. Because again, with the distributed nature, for them to be able to pull even on limited connections, that is actually a huge ability to get those speeds that they need. And all the rest over here are just some of the, I don't want to say supportive configurations here, but by setting certain buffer sizes and how that information is going to be transferred, again, it's helped out a lot. Here's the thing, I think the legal disclaimer is it depends on your connection speed, your hardware, et cetera, but honestly, this has worked. This setup I've shared with other folks I know at studios doing the same things, and this exact same process has worked beautifully for them as well. So again, if you're working in a distributed kind of remote nature, these are awesome settings to start with, but again, you may have to modify them based on your setup. Okay, so talking about Perforce Streams, this is an awesome feature. Again, the nature of our studio is that we work on a lot of projects, but what we don't want to do, and what Perforce Streams solves for us, is we don't want to have to constantly download, extract the engine. So in this example, UE 5.0.1, .2, .3, et cetera. We don't want to do that on a regular basis, so Perforce has the ability to utilize something called a stream. And essentially what it is it's a logical mapping from wherever those files are stored into your project. So in this example, you can see the main project, so it's the blue lines. That's our unique file. So that's specific to the project. We're not going to move anywhere else. We've also got things like plugins we've built or content. Say, for example, libraries of assets that we use quite frequently, different tools in DLC. We can actually stream all that in there. And the advantage with this is, if I kind of take a look at this one, the big advantage that we have with that is it means we only have to modify those files once. So in this case, the engine files that are on the right, we only have to do that one time, but we can stream that information into our projects as needed. So in this one, maybe again, client requirements are projects B and C have to use the latest of Unreal, but we're still behind on project D that we need to stay locked down on 5.0.1. Again, the cool part about this is those can be our core files. And then kind of jumping back here, you can see that even though we've got studio stuff, we can absolutely stream in additional information. And what it looks like on the end user is exactly this. It looks like just a regular project. It looks like they have all their files. They don't have to worry about what is actually streamed in and what is local on there. But one of the cool parts here too, so from the admin level, if you're trying to figure out what information is streamed in, it's the little, kind of like little halo ring with the green circle. That means that that file is being streamed in from somewhere else. And you can see on the right here too, you can actually view those streams. So in this case, we have one called UE5 Integrate. That is our core engine files that we use for projects. And in this case, you can see that we can stream it out to other projects. And again, only having to manage that information once. And then we've got P4 type maps. So this kind of goes back in a little bit to some of the back-end stuff. This is an amazing tool. If you guys have ever worked with the engine or you've ever had to version files, you'll know that when you push them, there's certain files that need to be writable in a user's workspace. So for example, there are DLLs that are shipped with your project. And by default, Perforce is going to lock those, which means if you're working with a source engine or a source version of the engine, and the user tries to go get it, they're going to get all kinds of warnings saying files locked, et cetera. Before type map, or I should say sheepishly, before I knew the type map existed, that meant every time we had a project, we'd actually have to go in and manually specify all of our DLLs that they needed to be writable in the user's workspace. The cool part is that we have a fun little robot in the back called type map that when you specify whatever it is with the actual file, it can do those things for you. So on the right, which I blew it up actually in the bottom left here, you can see that I did just that. So third line down, we have binary plus S32W. And basically what that is, that's just shorthand for any time that you see a .dll in your project, when Perforce sees that, I want you to go ahead and set that to writable, and I want you to only keep 32 versions. So only keep the last 32 versions of that file so we can keep bloat down. And you can see that we can do that for all different kinds of things. There's many different commands, but the cool part about this and what this looks like is as soon as those files are added to the depot, so the first time they're added, it compares against the type map, and it says, okay, anything that falls within these criteria, automatically set it. So now we've shaved off what used to take us about anywhere from a day or 2 days to build a source engine from scratch. We can now actually do it in about 4 hours. So, and this has been one of the big helps for that. And then I don't know if anybody here has used, we call it UGS, it's Unreal Game Sync. This actually ships with the engine. This is a tool that had its birth origins from Fortnite, but proved to be actually so nice that I think the community demanded to release it, and it's actually built in. The thing though is, one of the limitations right now is, while it does have a front-end GUI, you have to build that first. But the cool part is, and you can kind of see here, and sorry for all the redactions, NDAs, we've all been there. But you can see at the top there, the tabs across the top. This is actually a screenshot from my UGS client, and actively right now I have 5 different projects that we work on. So your UGS client doesn't have to be built for every single project. You can build it once and use it for anything. The big advantage that you have with using UGS, so this is a layer on top of Perforce. And I will say, I believe it only does work with Perforce right now, but this is an extra layer on top that actually helps your folks to stay focused on a project and not have to sift through every single change that's ever been submitted to Perforce. There's also a lot of robust functionality behind it. So if you look down kind of at the 3 images that are stacked on kind of the middle, you'll see that actually there's some really cool things that when you implement the metadata server with it, you can actually start marking builds, which is really good. So I could say, for example, we could say we're going into a code freeze for this week, and we don't want to block our artists, so we want to make sure that they understand, like, hey, you guys can still keep working because you're pushing content, not code. We can actually flag this in UGS, their client, and say, only pull latest known good. And by using this meta information, in fact, you can see a little green dot there, that is one that was marked as good, and that means they will only sync to that. So from the artist perspective, again, not knocking artists, but they're not really super concerned about probably like, oh, I need to know what CO went in, was a code change, right? Their primary focus is sync latest so I can get to working. So by enabling this in UGS, you see that it actually helps to unblock them a little bit. So they're not like, hey, my build's broken, stopping engineers, what happened? Oh, well, because you're on the wrong CL. So UGS is a pretty amazing tool to use on top of that. And then one of the other things here too, I didn't really cover this too much, but you can actually put a dedicated machine on your network. Doesn't have to be anything crazy, just a good CPU that can actually pre-compile your binaries. So again, if anybody's worked with consoles or you have to work with the source engine, you know you have to compile the engine whenever new code changes go in. So by having that dedicated machine on your network, you can actually take advantage of some of your automation. And in the client, you can actually set pre-compiled binaries. This has been a huge lifesaver, especially from a distributed perspective, because all of our folks may have different hardware, and some may have slower PCs that trying to compile the engine will take hours. But by doing this, literally what UGS will do is sync up to your machine that's automatically compiling the binaries, zip them up, and then for the user, you just hit sync, it pulls down the new changes, and it will unzip that for you. No need to compile. So that is a huge, huge win when it comes to distributed teams, and especially when you have varying degrees of hardware. Cool. And then this will be the last, and I'll hopefully try to get some time in this. This is really more just food for thought. This is really just more of a holistic approach when it comes to building your projects and working with source control. From this example, you can see this is one that we built, and I actually blew up here sublevels. So this is one way that we've worked where we've segmented our world out. So we have cinema. So for example, cameras, lighting, whatever we need to do. We have a nighttime environment, a daytime environment, as well as some of our time of day lighting. The key here is when you're working with source control, typically only one person can have a file checked out at one time. So instead of just having one map to rule them all, we actually have it comprised of, I believe, 5 sublevels plus a persistent. So theoretically, 6 people could be working on this level at any given time. So that's one method that, again, if you know you're going into a process where you're going to be distributed, you're going to have lots of folks in, this is a great way. Now, I don't know if anybody sat in Sam's talk a little bit earlier, but talking about the new open world tools, slightly different approach, but it's the same concept that you don't want to have just one master file. You want to have the ability for folks to be able to check files out as you go. So sublevels are a great way to do that. Another thing here too, so if you're working with any kind of sequencer-based things or cinema, there's actually a really cool tool that we have built into the engine, which is the nested subscene. So you can actually see in the upper right image there, you'll see that we've actually broken down each of our shots into essentially respective departments, right? Animation department, audio department, lighting, camera, etc. Those are individual files, which again, going back to the example, theoretically, 5 people can be working on the shot at the exact same time. But if we had nested this into just a single master sequence, obviously that can only be checked out by one person. So that's another great time saving, and especially working in source control, distributed, great workflow to be able to help you out with that. And then this is another one too, shameless plug, actually there's another talk that I do on materials. This is just one approach to setting up materials. Again, this can go across assets, different systems, but in this particular one, we've actually used a material functions approach. So the idea here that all the little blue icons that you see are separate individual files, but collectively together make up a master shader. So in this particular one, I've got, what was it, 1, 2, 3, 4? 4 separate functions of this material, which means 4 separate people could be working on this material to get it to the state that it needs to. With that being said, we have a little bit of time. Yay, source control.